Okay, so the only thing that we haven't gone through yet is basically these two other functions, right? Find set size as well as the find number of sets. So if we were to go back here, so all we have to include is int set size, which is and elements as well, and another thing which is int number sets. Right. So during the initialization phase, the set size initially of each set is going to be 1, and the number of sets is just the number of elements, right? Initially, before anything is merged, right? And then the only other thing that we need to do is whenever we merge the sets, over here we can just do minus number of sets, right? So we decrement the counter of the number of sets by 1 since we are merging two sets. And we include it here because we know that if it's already in the same set, then we are not merging, and then the number of sets does not decrement. And over here, right, since the parent of x is going to point towards y now, so the set size of y is going to be incremented by the set size of x. Right. Similarly, in this case, right, if the parent of y is going to be x, then the set size of x is going to be incremented by the set size of y, right? And so this by itself is almost everything. So if you want to find the set size, it's just referring to the corresponding index in this array, and the find number of sets, you can just return number of sets. And that's about it. So the main thing here is really these two heuristics, path compression and union by rank. Just remember that union by rank is really something about it's about the height of your tree, and it's implemented in the merge sets function, and it's really to make sure that we do not naively combine the sets, right? But rather we compare the rank. So this thing is called rank rather than height because really after we implement path compression as well, it's really not the height of the tree because as we saw in our example here, right? In this example, initially the height of this tree might be n, right? But after we do path compression, this is going to reduce to actually 1, right? Because everything is going to get compressed. So even though the height of the tree becomes 1, realize that when we do find set, when we're doing the path compression, we actually do not update the rank. So this is why it's called rank and not height, because it's really not the height of the tree. But it's still a good heuristic in order for us to be able to roughly balance out the height of the trees. Right? So once again, the second heuristic is path compression, and basically just by adding this, right? Just by adding parent of I equals to this, we are able to achieve this. Yep, so that's all for union find.